Next, we have Shelley Stahl. She's the Assistant Director for the American Geophysical Union's Data Management Assessment Program. She works with scientific data repositories to improve their data management practices with the ultimate goal of elevating how research data is managed across the globe. Shelley's diverse experience as a program and project manager, software architect, database architect, performance and optimization analyst, data product provider, and data integration analyst provides her with the capability and development of practical and sustainable data management practices. Thank you for joining us.
And I'm humble too. So let me tell you first about AGU, American Geophysical Union. And one of the interesting things is, first of all, we are worldwide. So we are beyond just America, just beyond all the states. There's 144 countries. And we have 20 scholarly peer-reviewed journals, largest earth and space science journal in the universe. Why is that? Because we actually have scientists that have been on the space station, and we have scientists that have sent probes out into space, so it's very exciting. We will be celebrating our 100-year anniversary very soon, so that's very exciting. Scientific meetings, I'll tell you a little bit more about those. And we have a fabulous magazine which you can get the online copy of right now if you go on to eos.org, and it's written for folks who aren't necessarily scientists so that you can enjoy what's been found and discovered, and it's brought to you in the words that you and I can understand. And this is our message here is we're galvanizing our community. So let me keep going. Here's all of our journals, just to give you an idea of the breadth and depth of what we have out there. The scientists that submit their research for it to go through the entire process, and each of those journals has an editor-in-chief. This year, GeoHealth, we've already heard some speakers talk about how important the environment is and how that impacts our health and our ability to live in a healthy community. So we recognize that and have a new journal this year. Here's EOS. I'll keep going through all of that. Let me tell you about our fall meeting. So I don't know how many of you have been to extremely large events, but we've got 30,000 scientists that come together to present their research. This is phenomenal. There's an awful lot of interesting collaboration that takes place, and everything from oral presentations to posters. The top picture there is a very small portion of our poster hall. It's like 2 football fields long. It's huge. We were able to draw a pretty significant keynote speakers. Elon Musk was there last year, which was terrific. And that's me, a selfie with DJ Patil. Gotta tell you, it was a big Cinderella moment for me. I spent about an hour and a half with him just talking, frankly, about the things that we do at AGU with data, so that was pretty awesome. And we also have within this community a challenge to bring improved data management practices across all of the different scientific domains. So we're doing that with our data fair, and we're doing that again this year. So we target it towards the researchers, helping them improve their data management practices through things like this. So we have a data position statement at AGU, and this is a really big deal. It was written and implemented in the 1990s, where hardly any publishing house was doing this sort of thing. Data within our environment is a world heritage. We don't purge our data, we preserve it. So that earthquake that happened, you can't get that data back. We want to keep that data forever. So in our mind, our life cycle goes on and on. Those climate models, they have 100 years worth of data in them. They're huge. Anything where you're trying to do an important longitudinal study to see changes like that, the models are massive and they require that kind of data to ingest. So here are the challenges within the community when it comes to data repositories and the folks that are working with data. We've got mandates. We've talked about that yesterday and today, and I'm going to tell you a little bit more. The value of data, being able to curate it, where there's not enough time and not enough money and not enough expertise in each of the different data repositories to do all data at the same level of quality. So that's a challenge. How do we do that? Can we automate that? Wouldn't that be fabulous? And some of the other challenges. Let me tell you about a couple. So here's the OSTP, February 2013. anything that is funded by the government for research will be available, openly available, including the data. So that was a little bit of a scary moment for all of the federal entities that have their data not necessarily easily available. And that's going to go into effect, I believe, in a few days, October 1st. And we did help one of the repositories actually meet some of those goals. And I'll tell you about that shortly, but here's an idea of the kinds of data that we have coming in. This is just NOAA. So we've got satellite data, we've got data being picked up from instrumentation on airplanes, in situ instrumentation, different buoy networks, which is many, many buoys that are all connected together, putting their data into a single location. But it gives you an idea of the variation and the difficulty. And this is just climate data. This was published by one of our authors, Jonathan Overpeck, and it was a few years back, but it does show you that the model volume, so models generate their own data. So the data coming out of models as well as the data that's being generated from all the instrumentation is exponentially growing. And the challenges with actually having to access that, being able to analyze it, having computer systems, high-performance computing that's robust enough to handle it is extremely challenging and getting harder. Every time we put up a satellite, it has more instrumentation with more volume of data that's coming back down to us that we have to be able to ingest every second of every day and be able to handle that and curate it and manage it and then process it. This one's fun. I borrowed this from Leslie Wyborn. Leslie is she's a scientist, she's in Australia, and she works with us on some of our projects. And she was trying to explain to her community, and thus you as well, because this is perfect, there are really two kinds of data that we work with. One of them, big data, which is that heavy volume coming in from the satellites and constant Earth observing systems. And then the other one, which we call long tail, which was was originally coined some years ago, where it's, if you think about taking a look at what's happening in a particular location, the permafrost that we were just talking about, that's a huge issue, the melting permafrost. So if you go up to Alaska and you go to measure all of that, not only do you need to take a look at the permafrost, but you also have to look down into the solid Earth and above into the atmosphere, and you need to know about the hydrology of the area. What's the water vapor like? What's the wind? What's happening with the wind? And you take all of that kind of data and you put that into your analysis. That's long tail data. Those are different kinds of data that have to be curated differently. So that's challenging. It doesn't always get curated as the same level of quality all of the time because you may not have all the expertise looking at that in the same way. So here are the other kinds of challenges with long tail data. Usually, for instance, you'll probably maybe see the item there. It's located on a C drive. So your researcher is out there with their laptop, right? This is where your data is landing. And you're praying it gets onto a repository where it can actually be curated and preserved. So those challenges, so what AGU decided to do, two major items. One of them is to develop a training program for researchers and folks that work with data, curators and data managers, to help them with their skill sets. So that's in development. We're really hoping that goes well. But for me, I was brought on to implement their data management assessment program because I have a pretty significant data background. And so this is what I'm going to talk to you about. Other things we're doing, we're also working with the publishing community, supporting the effort to help them understand when they're receiving data from the authors for each of the publications, these are the things that you need to expect from the data repository that's being used. And because publishers have so much influence on how data is handled, because they require it in order to get the publication out, we're trying to help them bring the standard up and make sure everyone else is working to that same standard. That's really important for us to spend time on. And we also support coming up with best practices for different kinds of reproducibility within the scientific world, software, et cetera. So, all right, let me tell you about what I do. So you have all those challenges. I've just told you all about them. And you own a repository. You may or may not in this room, but let's pretend. Now, how do you solve it? How do you actually meet the objectives of what your repository needs to do? That can be pretty confusing. Not very many scientists or folks that are managing the repositories have a significant project management background. There's very little out there within the scientific community for what the best data management practices are within those kinds of repositories. So this is what AGU wanted to do. How can we help give a roadmap so that these folks can more easily meet their goals and the quality of how the repositories are working together across the community increases? This is fabulous. I love this. So here's what we did. The tool that we adopted, and I'll tell you about it in a second, helps to build a roadmap. Where are you now? Not where you thought you were, but where are you really? Where are you now? Where do you want to go? And the things that you need to do to change and get better to be in that successful position. You might want to be more efficient. You might want to be more consistent. You may have some sort of a training problem that you've run into. Keep in mind, a lot of the data managers within the scientific community do not have standard training. So right there you have a problem. You probably have folks with different techniques. Which one's better? Have you even thought about the fact that one of them is probably not as good as the other? And then the way we work this is it's tuned exactly to your organization. So what is it? So if you know the CMMI Institute, they were spun off of an organization called the Software Engineering Institute, which was an FFRDC out of Carnegie Mellon. So they have models, software acquisition, and services. They call them their constellations. So several years ago, they built their data management maturity model, and it was published in August of 2014. I was one of the peer reviewers. So that's how I knew about it. And when AGU was looking for someone to implement this model, I was delighted. I was so excited. There are 7 of us certified to implement the model. We're not proud of that number. We're really hoping there'll be others. So if you're interested in knowing about it and you want to try to have a tool and be part of this community, I would love to talk to you about it. The more the merrier. But it's a tough bar to jump to be able to be certified to do this. And there are 25 different process areas, and I'll give you a view of what those are in a moment. But let me tell you how we're using this. So within the research, within the scientific research community, it's not like an organization, a commercial organization, where everything that's managing the data is within the CEO's command, right? It's not like that. What we have are different roles in multiple communities that all have to work together to do something, to make a change, to make something better. And these are all the different ones. Funders can be anything from the government to a Sloan Foundation to something to that effect. Different publishers, for-profit, not-for-profit. Repositories are sometimes only funded for 5 years. Sometimes they're full-blown 100-year archives. Data managers and the researchers themselves actually generating the data, and libraries play an important role as well. So not everyone realizes that there's so many people involved in making these decisions that have to work together. We do a lot of collaborative conversations. We set up a lot of collaborative meetings to make changes. So that means we all have to fly together. Great picture. Yes, the hummingbird's a little big, so yes. Whoops. So here's the eye chart for you. Actually, I have yet one more eye chart, but for each one of these different pieces of the life cycle, and this is sort of a generic research life cycle. Within our community, we have, I don't know, about 20 different ones that people like, but they're all fairly similar. And this one pretty much matches the general life cycle. Something to know, you don't necessarily go sequentially. Sometimes within this life cycle, you have to go back, redo, and keep moving forward, which is why there's the inner hub. But each of the process areas that are part of the model align to our life cycle extremely well. And then we have, in addition to those, the ones that are on the right-hand side, which cross over the entire capability. So it's very difficult to know if you're improving unless you're measuring. It's very difficult to know if you have consistent practices across your team members without checking their quality. And there are fairly easy ways to do this. And people can get strung up on the fact that I'm talking about it as being measurement and analysis, where actually all I want to know is, are we staying the same, getting worse, or getting better? And can't we just make that an easy number to do? So I usually help you through all that. I'm going to tell you about 2 assessments we've done. So what an assessment is we prepare an organization for us to come in and spend about a week with them and find out in granular detail exactly what they do. And we've done that for these groups that are right here. 2 different kinds of groups. One within a government agency, so that's USGS. That's a long-tail repository that also houses community data, like projects, like a project team, including, by the way, so that you know how awesome this database is, our national maps are held within the science base. So when you want to get a map from the Geologic Survey, they get it out of this database, which is pretty awesome. And the other one is a NSF-funded data management organization specific to biological and chemical oceanography data, another top-notch group. So I'm going to walk you through this very quickly. So ScienceBase, I gave you kind of a high-level view of who they are. And so they provide web services and content management. And one of the reasons we chose them we had worked with them to do the assessment is they are looking to implement, this is some months back at this point, but they were looking to come up with a way to scale an implementation for the data release policy, the one that OSTP came out and said, your research and data shall be available. So like, okay, there's just a few of us. How do we do that? No problem. Let's talk about that. So we worked through each of those items. And here are their data management objectives. And they actually had some fairly lofty ones because they have a lot of regulation and requirements within, as a government agency itself. And one to highlight for you is they also wanted to be recognized from the publishing houses as an actual repository that was complying with all of the requirements from publishers, which are pretty steep, including AGUs. So we help them work through all of that. So the good news story here is I just had a follow-up meeting with them last week. I saw them at International Data Week, and they've almost completed implementing all of their initiatives. They are ready to go fully loaded for the October 1st requirement for having data available, and they have an entire group of folks that they have brought in from across USGS in order to help be data managers and extend their capability. So they've trained people across their entire footprint. So it was a fantastic story. BICUDIMO, which is how you say that acronym. This is a group. We were talking yesterday about open link data. One of the reasons I was excited to come here to do an assessment is they're one of the repositories that's furthest along on being able to share their data through a link, because within the scientific community, we don't encourage a whole lot of copying. Once it's in a repository, we'd rather you link to it, although copying does happen, so that can be another briefing. But they are solving the problem by a very robust implementation of open link data. And that's working really well. So as we went through each of these, went through their elements, they were a very robust organization. What they were looking from the assessment was an opportunity to be ready for their midterm review for their NSF grant. They wanted to be essentially a center of excellence. And they felt they had gotten that out. They also got some standardized data management training, and we helped them think through, they had several PIs and co-PIs that were about to retire. So they needed to have some way to sustain and be consistent through that transition. So we helped them with that. One of the things that we do with these assessments, we do have a confidentiality agreement. So what I'm telling you, they've already said in a public way. So if you need to know more details about it, I can connect you with the folks that were there, and we're likely to be willing to share their experiences. So for that, I will leave it there. So let me tell you about other kinds of objectives that folks have within our community. There are some certifications. Actually, they're fairly new. The Data Seal of Approval and the World Data System have actually come together, and last week announced their new certification program, which is now combined. And it's actually a very terrific basic program. And what it defines is a series of services that any particular data repository should have. That's pretty good. I'm going to talk to you a little bit more about it. Nestor's an extension. I believe they're out of Germany. And then the ISO standard 16363, this is for trustworthy digital repositories. This is a pretty steep standard. This is something that was actually developed by the planetary systems with heavy influence coming from NASA. Very steep. And the level of analysis and requirements is at the same level as the model that we're using for the DMM. The difference between the two is if you know what an ISO standard is, you've either met it or you didn't. There's no middle ground. But when you work within a process improvement capability like a maturity model, you're able to actually figure out where you are on that spectrum. So if you actually don't have enough resources or funds to actually meet that standard because there's some financial resources that are required, then you could actually meet it at an 80% level and know where you are. That doesn't mean you're in the standard, but it does mean you're on your way, which is a heck of a lot better than not doing it at all. Alrighty, so self-assessments are out there. I'm gonna put this up here. You can read the words, but my great example here is consider the fact that you want to live healthier and you know that you need to go out and work out for 45 minutes 3 times a week. Okay, great. So somebody says to me, Shelley, do you work out for 45 minutes 3 times a week? Oh, yeah, I sure do. Yeah, So then I get a trainer. Okay, Shelley, do you work out 45 minutes 3 times a week? Well, let me tell you, that walk to the metro to my office, not really. So big difference between having someone facilitate your conversation so you realize how a particular requirement or practice actually should be working for your environment. So instead of you saying, no, that's not for me, the facilitator says, yes, I'm so sorry. Actually, this will benefit you, and let me explain why. By the time I'm done explaining, they're like, oh my gosh, yes, of course it will benefit me. So pick your favorite. These are all of the different data management process areas. So just eyeball these and kind of get them in your head, and you'll understand why in a moment. I'm going to give you one more. Here's another. These are things that keep your processing consistent and sustainable over time. This means that your organization is actually supporting what's happening through policy and procedures and training and making sure the right people are in place. Okay, so there's that set. Okay, ready? Okay, good. Have those in your head. So along the left side are all the elements of the ISO standard, 16363. Along the top are all the elements of the data management maturity model, starting with the process areas and the consistency and sustainment. They're broken into 2 sections on the right. One of them that's a demarcation for a couple different levels. So the great thing here is you don't have to have every box filled in. The really great thing here is that every column has at least some sort of green box. Terrific. This is an outstanding alignment. Although I did find one weakness, and they know this, I shared this with them. So the one on the left-hand side there is a standard vocabulary or glossary or taxonomy. We would all agree that that would be important. And the one on the far right having to do with keeping sustainment is the capturing of your use cases when something actually happens and you need to be able to make a change in the process, you need to be writing them down. So both those things would be good. So my message to them was, hey, if we use the DMM to reach your standard, I'll include those 2 things in, don't worry. So here's the starter certification, the DS, Data Seal of Approval, a World Data System requirement. And they actually talk about theirs as being fairly lightweight. And this demonstrates, yes, that's fairly lightweight. And the message here is there's very little having to do with sustainability, which is a concern because we have organizations out there that are adopting this, not realizing that all they're getting is a check mark of services and not necessarily a whole sustaining environment for the repository. It is a fabulous start, though. If you can get here, then you can keep going. So this is a great first effort. So that would be my message here. So just for your summary, if we can manage our data better, we can also do our science better. Scientists can find data more easily, they can use it for future effort, and this is really important to AGU. The assessments can help you reach any goal, and education can help you as well. We're finding that some folks don't even realize what the different data management best practices are. So starting with education will be fantastic, and assessment when you're ready. And the model works for anything, not just Earth and space science. It works for anything. So it's currently being used heavily within the financial community, and they're bringing it into, I believe, medical devices pretty soon. So thank you.